Okay, 3.1 notes. We got a note packet going with 3.1 notes. I'll go through some of this. There are a few things in there that you'll have to read on your own, a couple of pages, but I'll do some of the problems with you for the 3.1. Starts off with sketching each of the functions. We should know these parent functions from the past. The expectation is you know what they look like. So we've got y equals x, and then you've got y equals x squared, cubed. We know the cubed, a little swizzle in the middle. We got the reciprocal function, dealt with this a lot already. Got another one over here. Um, have 1 over x squared. 1 over x squared looks like that's going to be quadrant 1 and quadrant 2. And we got some totes, magotes there. Got the absolute value, square root. Got the e to the x. Remember, that's going to go through 0, 1, and then there's an asymptote there. Then the ln of x and the e to the x are actually inverses of one another. So this one goes up through 1, 0, and then continues on. Okay. So some functions that you probably should already know, and we'll be utilizing those as we move forward. We're back into the formal definition of a derivative. There are other ways that we can write the derivative. So the first one, all of these have to do with finding the difference between our point up here and point down here, and they're all going to be slopes, and they're all going to be very similar to one another. You can have, so this is the point we're talking about, and then we move h units forward, and that's where we took the limit as x approaches h, but this one would be the f of x plus h minus f of x, and then divided by the x plus h minus x. And then when you simplify this guy, you're going to end up with f of x plus h. This was the one that we probably used the most for the difference quotient. And then when we simplify the bottom, we get h, and then we worked out the limit as h approaches 0. You can also use this is where we're going to be down here, h units below and h units above. So we're going to kind of do the change in y over the change in x using these 2 points, which is going to get a little bit messy because I have the x plus h minus the f of x minus h. So that works as well. So this is like we're forward. Now we're symmetric. You can see why they're using these terms. Then this one will be the backward. And when I put it over x plus h minus x minus h, and when I simplify, I'm going to end up with the top's going to be the same. And then the bottom will end up being 2h. So that's going to be the symmetric one. Now the end one, we would do the same thing. I'm just going to give you the formula now. We're going backwards, so it's f of x minus f of x minus h. And then once I simplified the bottom, it would be x minus x plus minus h, and you would end up simplifying to h. So that's just putting the h value in different spots, and all of these can be used for alternative definitions of the derivative. You can do exactly the same thing, but you can use the change in x instead of the h's. So all of these are going to be exactly the same as the ones above, except instead of an h, you're going to have, this is where the h was there, h, 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 h. They use the change in x on that instead of the value of h. So I think you can probably develop those ones just from the ones from above, and and get them written in your notes. We took a look at a problem like this when we did one of the AP samples from the other day. Concert tickets went on sale at noon. That was time 0. Sold out in 9 hours. The number of people waiting in line to purchase tickets is modeled by twice differentiable function L. Use the data in the table to estimate, that's a key word there, the rate at which people waiting in line was changing at 5:30 or time 5.5. Show computations that lead to your answer and indicate the units of measure. So 5.5 is going to be halfway between 4 and 7. So these are the two that I'll find so the derivative of L with respect to t will be the L7. And again, we have to get into good practice of using our slope for the differentiation, which gives me 150 minus 126 over 7 minus 4, which is 24 thirds, which is 8 what? People per hour. So at 5:30, it was at 8 people per hour. They want the computations. They want the units of measure. This is going to be, she has written in her notes, very common AP3 response question. Since we've already did one in class together and we have another one here, I'm guessing we haven't seen the last of this. In one guy's opinion, mine, I don't think that that's very difficult either. Okay, big thing for 3.1 is going to be sketching the graph of the derivative. I think we just skipped over page 3, which is kind of things that we already saw when we did the difference quotient, and then we did the alternative definition of a derivative, which is what I just used. And then we did f prime y prime dy dx, and what is the relationship between f and f prime. So take a look at that page 3. And then when we want to graph a derivative, again, this is going to be a reasonable sketch. You aren't necessarily going to be exact. The first thing we're going to do is we're going to plot where the slope will be 0. Because essentially, if this is f of x, and then we're going to graph f prime, the first thing we want to do is plot where the slope is 0. And the slope is 0 when we have humps and bumps, horizontal tangents. So I go here. This will be slope of 0. So I know my point will have a 0 there. And I know I will have a 0 there. The next thing I can do is I can estimate where what the slope is in a few different points. So if I looked, let's say I went down right here, and I drew the tangent line, and it looks like so. I can estimate that slope to be about, I would say up 1, and then up 2, and then maybe right to the, I don't know, it's not 2. I don't believe that the slope here would be considered 2. I'd be up 2, right 1. So maybe, actually, from what I've drawn here, I think it might be a little bit more than 2. Because if I use this point and went up 2 and to the right a little more than 2, what if I did 2 1/4? What if I said that slope there is about 2 1/4? 2.25. Can I go from this point and say my slope was 2.25? So I got to be right about there. And then over here, I could say, let's look at this one. This seems pretty soft. And I come through with a tangent. And I think, well, it's less than 1. So what if I said the slope right here, if I did rise over down 1/2, right 2? Well, that's a slope of about -1/2. So what we're graphing, remember the derivative is the set of all slopes. The slope's 0 here, I got 2.25 there. So can I say this is -1/2 right here? I think so. And so we're going to be a parabola. It's going to go like this. Remember the degree that we start with, in this case it looks like a degree 3, so I should end up with a degree 2. Probably should have one more. Let's maybe head over to this spot right here. Try to get a slope off of there. If I can, and I believe I've got a slope of about, if I go up 1, up 2, right, a little, about 2. So let's call it a slope of 2. M equals a slope of 2. Again, they said reasonable sketch. So if I went up here, does it make sense that I can then connect my dots and make a parabola? I think so. So we have sketched a reasonable graph of the derivative. So the first thing we're doing is plotting where the slope is 0, and then we are calculating the slope at select points. So obviously you could see this in an AP setting where you're not going to have your calculator. Which one is going to be which for this guy right here? We're going to examine the slopes. The first thing I would do is I would examine the zeros here, here, and here, which means I have zeros. It can't be this one. Wrong zeros. This one has too many zeros. Nice pen. So these two work. How do I tell the difference? How do I tell the difference? Remember the graph of f prime. Oh, it says for each graph that you did not select, explain why it can't be. We need 3 zeros, wrong zeros, or I guess I should be more, need 3 zeros, need 3 zeros. There's too many zeros, need 3 zeros. That would be for both of these. This one, how do we tell the difference? I would go up here and I would think, how am I supposed to start? The slope at the beginning, the slope is negative. So if this is going to be the graphs of the slopes, which ones start in negative land? And the answer is this one. Slope starts in the negative land, has the correct number of zeros, seem to be in the correct spot. This one, I would say these are going to be positive values. So we would need to start with a negative slope. This one starts, these are the set of all slopes now. Negative land, 0, positive land. Negative slope, 0, positive slope. 0, negative slope, 0, positive slope. So we're graphing the slopes. Slopes, my goats. Next one, graph of the function is shown. Fill in the missing entries in the table. So they've got x values and they want the corresponding derivative. So when x is -2, what is the slope? That's what we're looking for. What is the slope right here? looking for the slope of the tangent line. I'd say down 2, right 1. I'd call that negative 2. Okay. Next, we need the slope at negative 1. That's going to be right here. What is the slope at negative 1? I'd call that down 1, right 2. I'd call that a half. What is the slope at 1? I'd call that down 3, left 2. Close enough. I think that's 3 over 2, 1.5. What is the slope at 2? Here's 2. I'd say it's the same as the one that we just did. 3 over 2. What is the slope at 4? Oh, we finally got a nice one. It's going to be 0. What is the slope at 5? Going to be like this. I'd call this down 3, right 2, negative 3 over 2. Negative 3 over 2. So the next thing they want you to do is they want you to sketch it. So I would take, if I had an eraser, I would erase this debacle. But now I'm just going to plot these points. So I'm going to go from, where is our origin? Origin must be here. So I'm going to plot the negative 2, negative 2, negative 1.5, 0.8, and 1, 3 over 2, and 2, 3 over 2, and 3, 1.1, and 4, 0, and 5, negative 1.5. So I think I had my origin in there incorrectly. There's the graph of the slopes. So we're finding the slopes at each of the values. Finding the slopes at each of the values. Good stuff. Sketch the graph of the derivative function of each of the given functions. Same thing. I'm actually going to start with C because what's the slope of the one on the right? I believe the slope of the one on the right is 1. What's the derivative of y equals x? It's y equals 1. We should have a horizontal line where y is 1. If you think about the next one, it looks like I get 0 right in the middle. It's a point of inflection. This is going to be the x cubed function. I have a positive slope, positive slope, positive slope, 0, positive slope, positive slope, positive slope. And it's going to be very steep coming in. Big values, steep values, and then going out. Positive big numbers for my negatives over here get to 0, positive big numbers. Think about the derivative of x cubed, 3x squared. There you go. Next one, I've got a 0 right here, so I know I'm going to be here. I've got a 0 right here. I've got a 0 right here. And if you think about the fact that this is probably an x to the 4th, now I'm going to need a x to the 3rd. So if you think about negative slopes, negative slopes, negative slopes, positive slopes, positive slopes, positive slopes, negative slopes, negative slopes, negative slopes, positive, positive, positive. So I start with negative slopes out here, then I get positive slopes in here, and then I get negative slopes over here, and then I get positive slopes to the end. So you're talking about the slopes. Negative, I'm going down until I get to this down here, and now I'm going up. So you can see the slope right here is going to be, that's a positive, steeper slope. The slope over here is negative. So when we graph the derivatives, we're graphing what is the slope of the actual graph at each point. Okay, I'm going to stop with the video there. You can now finish page 7 and 8. Hopefully I remembered to put the key to on Schoology. I may put the whole key for 3.1 on Schoology, but for sure page 7 and 8 will be there. Good times. Hope you enjoyed.